We have chapter 10 exercises. First we wanted the reciprocal of 2 over 5, that's 5 over 2. And then we wanted 3 fractions equivalent to 2 over 7, like multiply by 2 over 2, 4 over 14. Excuse me, I haven't set the clock yet. So 3 over 3, that's 6 over 21, multiplied by 4 over 4, that's 8 over 28. These answers are not unique. And then we wanted to reduce 14 over 35 times 36 over 77 times 49 over 24. I got a prime factorization, which is 2 times 2 times 2, 3 times 3, 7 times 7 times 7, over 2 times 2 times 2, 3 times 5 times 7, 7 times 11. I'll repeat. 2 times 2 times 2, 3 times 3, 7 times 7 times 7, divided by 2 times 2 times 2 times 3 times 5 times 7 times 7 times 11. And when you reduce, you are supposed to get 21 over 55. Excuse me for going a little bit fast. We have a lot to cover. So you were supposed to do this, just use that as a check, not to start doing your work now. Then we wanted to reduce 12 plus 18 over 3 plus 2, which gave us 30 over 5, which is equal to 6. Okay? So 12 plus 18 over 3 plus 5, 3 plus 2 I mean, which is 30 over 5 or 6. And I hope you didn't get 6.5 because that is wrong. As you can see here, you cannot reduce unless you can factor out. So if you have pluses or minus, be careful. You have another reduction. 12 over 35 times 21 over 4. All of that divided by all of 9 over 10 plus 26 over 11. And when you reduce that, when you multiply by the reciprocal, you are supposed to get 2 times 2 times 3 over 5 times 7. That was the first fraction. 3 times 7 over 2 times 2, that's the second fraction. 2 times 5 over 3 times 3, that's the third fraction. And finally, 11 over 26, which is 11 over 2 times 13. And, oops. And when you reduce all of that, you're supposed to come up with 11 over 13. Again, this is work that you should have done, so I should just show you the answer. Then we wanted to find the product of 6 and 2/3 with 5 and 1/2. Convert that to 20 over 3 times 11 over 2. Reduce, 2 goes in here 10 times, you get 110 over 3, which you want to write as a mixed number, 36 and 2/3. Because you started with a mixed number, you want to end with a mixed number. Then you wanted to divide 6 and 2/3 by 9 and 1/3. That means you multiply 20 over 3 by 28 over 3, you divide, so you multiply by the reciprocal, which is 3 over 28. 20 over 3 times 3 over 28, which should be 4 over 7. Take a quick look at that. Then we wanted to simplify 1 over 3 minus 1 over 7 divided by 1 over 9 minus 1 over 49. The least common denominator is 49. Multiply by 49 over 49. Distribute. 1 times 49, 49, 49, 49. 9 over 3 gives you 2. 49 over 7 gives you 7. 9 over 9 gives you 1. 49 over 9 gives you 1. You should get 3 times 49 minus 9 times 7 over 49 minus 9. Yes? No? Okay. which is supposed to end up with 21 over 10. How are we doing? You wanted to evaluate a squared plus 5b over a minus 3b, where a was 21, b was 7, a was 21, b was 7. Your denominator gave you 21 minus 21 or 0. The numerator is immaterial. This fraction is undefined. Okay? 0 in the denominator, that's a big no-no. Remember that. Lots of people get that wrong. We are now in the second set of exercises. The answers. This is chapter 11. We wanted to write a 7-digit number that had, I guess, a 3 in the million place, a 5 in the 10,000 place, a 7 in the 100 place, a 2 in the 10, and a 5 in the 1 place, and a 0 over here. So 3,050,725, which I wanted to write in words here, 3,050,725, with a half hyphen between the teens and the ones. So these two problems are really backwards of each other. One goes to the other one. Write the decimal form for 29,029, 29,026. I say 29, I have 26 here. And 60 and 62,005 millions. 62,005, 10, 100,000, 10,000, 100,000, millions. And then which of these two is bigger, 5.1 or 4.9? 5.1 is bigger. And then we wanted to round 3.249, that's 3 and 249 thousandths to the nearest hundred. Circle the nearest hundred. And the first digit you drop is more than 5, so bump that up to the next one, so that's 3.25. 3.25. Round this one to the nearest hundreds, well, bump it up all the way to the right. That's 3.30. And, okay. This one, we want to round to the nearest hundred again. That should remain 3.95. Why do I bump it up? We want to round to the nearest hundred. Oh, that's a comma here. Okay, there is a misprint somewhere. I'm not sure whether I want to keep the comma or whether I want it to be the hundredth. With the comma, okay? These are all supposed to be commas. I want to write to the nearest hundred, so that gets bumped up to 4,000. Not decimal points, commas here. And then we wanted this number, we wanted a number that rounds to the nearest hundredths. So what should be the smallest number that goes into this? What is the smallest? A number that's less than that. So that's a 2. 2, 1, 2, 2, 2, 3, 2, 4 all go down. 2, 5 goes up. So 2, 5 right here. 5.925. 5.925. That should be it. Then this one is optional. If you can do this one, you're pretty good. This is a repeating decimal. We wanted to show that this can be written as a ratio of two integers. What I did is I moved the decimal point to right after the first repeating group of decimals. So I had to multiply by 10 to the 4, 1, 2, 3, 4 places. And to move it right before, I had to move it 2 places, so multiply by 100. Subtract these two lines, the 1s and the 9s on line up. You get infinitely many zeros, which you can forget about. I let you catch up on this. I did a little bit fast. I want the decimal point right after and right before. I want to subtract the two. I get a string of zeros. 24 subtracted from 2419 is 2,395. 100 subtracted from 10,000. I had to use a power because I don't have enough room to do that. Leaves me with 9,900. So 9,900 times the number is 2,395. Do a division. Divide both sides by 9,900. You get the following. If you have a calculator, which you're not supposed to use, you can use it as a check and see if you get indeed 24.191919 and so on. And you're supposed to be able to reduce it to 59 over 165. So this particular problem was optional. If you got that, congratulations. You're doing pretty well. Then we have the solutions to the next problem. We had an irregular hexagon with these sides, 3.5 and so on, and we wanted to add those numbers. And when we add these numbers, I came out with 39.7. These points are decimal points. I want to make sure that they line up, therefore they look so funny. Okay? They're not multiplication, they're decimal points. Did you get 39.7? And Millie had so much money left in her checking account after paying for repairs. How much did she have before? We add 94.5 to 53.5, gives us 148.0, so just 148. You have two carries here. A carry from the 5 plus 5, which is 10, and a carry from the 9 plus 5, which is 14. On Friday, the receipt said the concert was $239.20. On Saturday, it was $99.90 more. So how much did they have on Saturday? Almost 100 more than that. The answer should be around 339, probably 10 cents. Let's see. Yeah, $339.10. No need for the zeros here, but when you say cents, you say 10 cents. You notice this is almost 100. 100 more than this is 339. And you're off by 10 cents. Again, if you do it step by step, you have three carries right up here. Okay, I can go on. You're copying this, you're checking it. If you make a mistake, check it later. Don't try to check it now. Find out where you went wrong, okay? Regular price of a suit was $470. It is marked down $88.99. How much do you have to pay after this markdown? This number minus that number. And you need a couple of borrows. So 307. This is really 4. I had to open a box of 100 to be left with 3 boxes of 100, get 10 boxes of 10. And I had to open 1 box of 10. That gave me 10 boxes of 1. So this is 17, 9 from 17, 2 from 10, and 0 from 3. So I had to pay, I guess, $329. The seating capacity in the Los Angeles Coliseum in 1 year was 105,000. So 105,000, that's really 105,000. And in 1976, there were 92.604 thousand. That's 92,604. Just 1,000 then. I'm working with 1,000 boxes, so I have 0.6 of the box. That's 1,000 box. How many seats were there in 1976? There were, where am I? 95 to 105. In 78, there were 92. How many were there in 96? I guess I have to subtract the 2. And there were 12.3 396,000 more seats in 35 than there were in 76. Okay. You subtract the two. It looks like there's something missing here. You have 105,000 less this. So 105 minus 92. Yeah, you see the 1 goes here. The 100 became 10 tens, therefore this is correct. I had to borrow, and then I can do my subtraction. The Eiffel Tower, I don't think we got to, so I'm not going to do it here either. I recall I ran out of time last time. If you wanted to take the numbers down, you have 1.17 thousandths feet less in the Eiffel Tower than in the Tokyo Sky Tree. And then your grocery shopping, you bought as many items as you have here. You have $40 in your wallet, is that enough? A quick approximation, you have about $5 plus $4, about $9, $13, $6. The total comes out to about $37. It looks like you have enough if you have $40 in your wallet. This line should not be here, so erase it. Okay. I'm back. I'm now doing chapter 13 in my book, which is multiplying decimals. And in your textbook, in the section 3.3, multiplying decimals, 3.4, dividing decimals. So we want to start with the basics. The product of 3 and 4 is 12. The product of 0.3, that's 3 over 10, and 4 is 3 over 10 times 4 over 1. So 12 over 10, or 1 and 2/10, or 1.2. There should be no 0 right here. The second 0 is a misprint. The product of 0.03 is 3 over 104, so that gives you 12 over 100, which is 0.12, 12 hundredths. I'm trying to find out what I can do with the decimal point. 0.003 is 3 over 1,000 times 4, that's 12 over 1,000, 12 thousandths. I guess the decimal point is 3 places to the left. Before it was 2 places and then 1 place. And if I multiply 3 hundredths with 4 hundredths, I get 12 10,000ths. 10,000, the decimal point needs to move 4 places to the left. The examination of the above results shows that when we multiply the factors, if there were no decimal point, then first multiply as if there was no decimal point, and then move the decimal point as many places as you have in both of the factors that you multiply. The multiplicand and the multiplier, I think that's what it's called. Now, when you multiply by 0.1, just move the decimal point 1 place, by 0.01 2 places, by 0.001 3 places. So multiplying by 0.0 and a number of zeros and then a 1 is really very simple. Leave the number in place, just move the decimal point. As many places as you have right here. So multiply 123.4567 by 0.001. Take the decimal point, move it 1, 2, 3 places to the left. You get 0.1234567. You can decide what you should really call it. It's easier to read it as 0.1234567. If you were to write it, don't write it 0. Blah blah blah. Now here's an interesting one. What is 0.01 to the power 3? 0.01 times 0.01 times 0.01. 1 times 1 times 1 is 1. How many places? 2, 4, 6. 1, 2, 3, 4, 5, 6. Okay, so you have 5 zeros here. What? That's a very small number, isn't it? What would you expect 0.01 or 0.001 to the 1,000 to be close to? Oh, that's an easy one. This gets smaller and smaller and smaller. You get closer and closer and closer to 0. if you have a calculator, if you know how to do exponents on your scientific or graphing calculator, see what that becomes. You'll probably get 1 times 10 to the negative, a big number, negative 100, negative 200. That means you have 100 or 200 zeros before the 1. Find the product of 10 and 0.3. When you multiply by 10, all you have to do is move the decimal point 1 place to the right. When you there's a decimal point here, just move it 1 place to the right, you get 30. When you divide by 10, you move the decimal point to the left. Remember 50. 10 times 50 is 500, the decimal point goes to the right. Divide 50 by 10, that's 5, the decimal point moved to the left. This one example will keep you on track as to whether you move to the right or the left. I didn't set the time. Oh dear. Then we wanted properties of multiplication. We have the identity for multiplication. 1 is still the identity. 1 times a number is still that number. 0 times any number is 0. The commutative property of multiplication. The 5 and the 0.7 can switch places. I show you that 0.07 times 5 is the same as 5 times 0.07. That's for commuting. This is the associative property. 3 times 0.04, 3 times 0.4 times 5. Multiply 3 by 0.4, that's 1.2, and then you get 6. Or multiply 0.4 times 5, you get 2, and then you get 6. Okay? So this is for the associative property. For the distributive property, you would need a plus here and a plus here. So distributive property of multiplication over addition and subtraction. It's not quite what I'm showing here. This belongs up here. And down here I should have A plus B plus C, the A together with the B, A plus B plus C, and the B together with the C. Sorry for that misprint. Don't get confused, don't get messed up. What are multiples? A multiple is a number multiplied by a natural number. Like a multiple of 0.4 is 0.4, 2 times 0.4, 3 times 0.4, 4 times 0.4, 5 times 0.4, and so on, and so on. And then, let me see how much time I have. Oh, I still have time before my next class. Examples. I want to simplify this entire expression. Remember PAMDAS, your dear Aunt Sally? Please, the middlemost set of parentheses, group is right here. You get 0.3 times 0.3, that's 0.09. You get 0.2 times 0.2 times 0.2, that's 0.08. So do that first. Do a subtraction later. You get 0.082. You're down to one number. Your next group is the brackets. In the brackets you have a multiplication, and then you have a subtraction, then you have another subtraction. I let you copy this one step at a time. When we are down to one number here, the whole expression is our P. We start over again. Are there any exponents? No. Multiplication or division from left to right, there's a multiplication. And this product is supposed to be 1.608. And the addition is supposed to give you exactly 2. Okay, can I go on? An auditorium has 35 rows of seats, and each row has 254 seats. Each seat is occupied during a performance, and there are no freebies, so everybody pays. The state tax revenue is $3.07 per admission ticket. How much did the state collect from this performance? There are 254 seats in the first row, plus 254 in the second, plus 254 in the third. I keep adding, that's a multiplication. And when you multiply 254 by 35, you're supposed to get 8,890. You want to copy that quickly or check if that agrees with what you had done. So the state revenue is 8,890 times what they get per one ticket, 3.04, which is supposed to be, I have a decimal point here, so move back, that's $27,292.30. This line of zeros you don't really need, so you can move the third row up one to the second row. And I think I'm showing you this in the next step. Right here. Again, the decimal point should be right here. So nothing new here, nothing really new. A box of Hershey Kisses costs $7.25. A box of Ghirardelli dark chocolate costs $17.50. What's the total cost for 25 boxes of Kisses and 12 boxes of dark chocolates? You multiply the cost of one chocolate of Hershey by 25, and one cost of Ghirardelli's chocolates, dark chocolates, by 12, which is supposed to give you 181.25 and 210. And when you add those two, you should get $391.25. You can check these numbers. You wanted to find the area of the following figure. I guess here you have a rectangle is length times width, or base times height. You need to find out what this number is. It is 2 minus 1.2.8. You need to find, that was this number. And you need to find what this number is. That's a total of 3 minus 0.7, so 2.3. You can make this a big rectangle from which you cut out the following. So the big rectangle is 3 times 2, and then you multiply the, what did I say, 2.3 with 0.8, and you subtract that. Or you can cut this into two pieces. I'll show you down here. Well, I'm not showing you here. And you can subtract the two, and you're supposed to get 4.16, so 4 1/1600 square yards. Alternately, you can put a line either here and here and make it 2 individual rectangles. You could even make it 3 rectangles by putting a line here and here, but that's not necessary. And if you do it that way, you also get 4.16 square yards. Okay. 3 times 1.2 plus 0.7 times 0.8. And then you wanted to find the product of 1,467.29 and 1,000. 1,000 makes it bigger, move 1, 2, 3 places to the right, so you get a 290. And then you want to get a set of exercises, to which I give you the answers next time. The first one, simplify 0.92 plus 0.5, open brackets, 60 times, open parentheses, 0.3 to the power 3, minus 0.2 to the power 4, close parentheses, minus 0.9, minus 0.6524, close brackets. Then exercise 2. An auditorium has 25 rows of seats. Each row has 30 seats. Each row is occupied. There are no freebies. The state collects $2.09 per admission. How much does the state collect in total? The numbers were 25 rows of seats, 30 seats in each row, and the state collects $2.09 per seat. A box of Hershey Kisses costs $8.50, and the Ghirardelli dark chocolates cost $18.25. Maybe it'll be that expensive, or maybe more expensive by the time you read this. What is the total cost for 22 boxes of Kisses and 10 boxes of dark chocolates? So $8.50, $18.25, 22 of the first kind, and 10 of the second kind. Then, find the area of the following figure. You have an L-shaped figure. You have 0.9 yards up here, 4.1 yards on the right side, 4.0 yards on the bottom, 3.2 on the left, Y horizontally, and X vertically here. So find the area. All of this is like the examples we went over. Find the product of 0.537109 and 1,000. Okay, I'll get you the answers on the next video. Enjoy your week. I'm going to cut it now, and I'll bring back the other chapter or chapters. Okay, we are continuing with chapter 14 now. And in chapter 14, we are dividing decimals. Let's go back over the basics. We defined division in terms of multiplication. Remember when we had 12 divided by 4, which was 3? This was because when we multiplied the denominator or divisor by the quotient, the 4 times 3, we got the numerator or dividend. So now I want to divide 1.2 by 0.4, and that's a 3, because 0.4 or 0.4 times 3 is equal to 1.2. So division in terms of multiplication. Also, division in terms of repeated subtraction. Remember when you do the algorithm, the division algorithm, you keep multiplying and you subtract. So here, I want to take 1.2 minus 0.4 once. That gives me 0.8. Can I do it the second time? Yes. The second time I do it, I'm left with 0.4. Can I do it the third time? Yes. The third time I subtract 0.4 from 0.4, I get 0. Can I do it the fourth time? No, I don't have anything left to take this from. So this could be done 3 times, namely a positive 3. The dividend is a number that you divide into, that can have a decimal point, but not the divisor or the number you divide by. That is to be no decimal in the divisor, in the number you divide by. You divide by, yeah. And we stated that we could have a remainder, or we could keep on subtracting by appending insignificant zeros. Now, what do I mean by that? Suppose I want to divide 1.3 by 4. We said the decimal point in the numerator is okay, the decimal point in the denominator is not. The denominator is 4. And the quotient is 0.325. And why is that? Well, we have 1.3, which we are dividing by 4. So 4 goes into 1, it doesn't. The decimal point is reproduced in the same vertical position. Spread these columns out so that you don't make a mistake down here. And we said 3 times. 3 times 4 is 12. Once you have the decimal point, forget about the decimal point and do your division the regular way. So 3 times 4 is 12, which you subtract, you're left with a 1. You take down the next digit, which is a 0. You can have as many zeros as you want here. That gives you 10. 4 goes into 10 twice. 2 times 4 is 8. You subtract 8, you get a 2. You take down the next digit, which is 0. And 4 goes into 25 times. And you're left with a 0. So 0.325, which you would write as 325 1000 thousandths, 325 thousandths. Now it's easier to say 0.325 just as a matter of convenience. You don't have to scratch your head, gee, what are these thousands, what digit is in what place? But when you write it, don't write it 0.325, okay? Write it as 325 thousandths with the TH. Okay. Suppose we wanted to divide 140.273 by 0.0203. So we are dividing by a decimal, which we said is a no-no. Suppose we write the division in terms of a fraction. The numerator 140.273, the denominator 0.0203. Multiply by 10,000, numerator and denominator. This is 1, so you can do it. And you get 1, 2, 3, 4 places to the right. So 1, 2, 3, 4. And in the numerator, 1, 2, 3, 4, you need an extra 0. So students like to say, move the decimal point 4 places to the right in the numerator and the denominator. Okay. We want to divide 203 into 1,402,730. Can we subtract? How often does 203 go into 1? It doesn't. Into 14? It doesn't. Into 140? It doesn't. Into 1,402, my first guess was 6. 6 times 2 is 12. That's a pretty good guess. You have a 0 here, so 6 times 2, 12. And 6 times 3 is 18, carry 1. There's a 1. 6 times 2 is 12. Subtract, you're going to get a 4 here. After you borrow from here, you're left with a 1. And you have to borrow here also. And you get an 8 here. Okay, so you have to borrow, that's an 8. A quick check. This is 12, this is 10, this is 14, there's my 14. So I'm finished with that part. Take down the next digit, which is a 3. I reproduce what I had up to this point. That was a 7. And that was this 7 right here. And then I'm at 1,847. How often does 200 go into 1,800 something? Probably 9 times. 9 times 3 is 27, carry 2. There's the 2. 9 times 3 is 18. Subtract, you get 20. So I'm at this position now. Take down the next digit, which is a 3. There are more 2 digits needed up here. And we'll continue with the 203. There's my 203 from above. How often does 203 go into 203? Once. That's above the digit 3. 1 times 203 is 203, which I subtract, that's a 0. I am not finished, there's another 0 here, and in that 0, 203 goes 0 times. So 6,000. My answer then is 6,910. The quotient of 140.273 and 0.0203 is 6,910. So far we have seen terminating decimals. In other words, there's no remainder after a certain point. Below is a repeating decimal. Okay? A repeating decimal. Suppose we want to divide by 1.234 by 1.5. The first thing I do is I multiply by 10 over 10, which makes the 1.5 become 15. And the 1.234 becomes 12.34. And 15 into this is less than 1, so my result is 0 point something. Could I tell approximately what the answer should be? 12 and 15. 3 goes in here 4 times, in here 5 times. That's about 4 over 5 or 8 over 10. The answer should be a little bit more than 0.8. There we go, 0.8. Okay. I guess I have done all the work at once. How often does 15 go into 1? It doesn't. Into 12 it doesn't. I could put a 0 here or leave it blank. The decimal point is reproduced in the same position, always. And then you can ignore the decimal point. And then how often does 15 go into 123? About 8 times. 8 times 15, 8 times 5 is 40, carry 4. 8 times 1 is 4. 8 times 1 is 8, and 4 is 12. So subtract 120, that gives you a 3. Take down the next digit, 4. What do you multiply 15 by to get 34? 2. 2 times 15 is 30, which you subtract, that gives you a 4 here. Take down the next digit, that's a 0. And in 40, 15 goes twice again. Right here, that 2. And that's 30, and you subtract, that gives you 10. Take down the next digit, that's a 0. And notice you had a 10 here. And you have a 30 here, a 30 here. The 30 is going to repeat. So you're going to get 6, 6, 6, 6, 6, and so on. And this is the 6 is repeated indefinitely all the way to infinity. You could write this exactly as 0.8226. The 6 with the bar signifies that whatever digit or digits is under the bar gets repeated all the way to infinity. 6, 6, 6, and so on. And if you need to round, it's up to you how much rounding you want to do. If you want to round to the 10, 100,000, 10,000, 100,000 place, that becomes a 7. Okay. I guess we want to divide 8.25 by 275. About what might the answer be? 8 over 240, about 1 over 30, about, what do I have in mind? 8 goes into 24 3 times, so it's like 1 over 3, a little bit more than 1 over 3. About 1 over 300, about 0.003, something like that. We'll see. I'm just trying to guess very quickly. Okay. So we are dividing 275 into 8.25. I want to multiply. Yeah, that's 275. There's no decimal in it. I got confused for a moment because I saw a decimal here and I was thinking of that. So how often does 275 go into 8? It doesn't. The decimal point is reproduced in the same position. How often does 275 go into 82? It doesn't. But you need a 0 here, because after the decimal point, you need to account for your tenths. How often does it go into 825? 3 times? 3 times 5 is 15. 3 times 7, 21, and 1, 22. 3 times 2, 6, and 2, 8. Your remainder is 0. It goes exactly 0.03. The point here was be careful that you have a 0 right in that position. Then I wanted to evaluate a squared plus 3b squared over 10a minus 3b if a is 1.2 and b is 4. That looks like 1.2 squared minus 3 times 4 squared over 10 times 1.2 minus 3 times 4. Open parentheses, drop your numbers in, and then crank out the numbers. 1.2 times 1.2 is 1.44. 3 times 16, that's a times, not a decimal point. Decimal point here, multiplication sign here. Remember the confusion between the two? Be careful. And then the denominator is 12 minus 12. Ooh, what is 12 minus 12? It's 0. We are dividing by 0. And what did I tell you about dividing by 0? That's a no-no. Do not divide by 0. Do not have a 0 in the denominator as a factor. So this fraction is undefined. You want to evaluate this? There is no evaluation. Then I had a minus 30b over 100a squared minus 3b squared, where a is 12 and b is 0.4. So plug in 12, plug in 0.4, 12 squared, 0.4 squared. That gives you 12 minus 12 in the numerator. The denominator is not 0. 0 over a number is 0. 0 in the numerator is good. 0 in the denominator is a no-no. Now be careful. Don't say 0 is undefined. The fraction divided by 0, that's undefined. Okay, so 0 in the denominator makes division by 0 undefined. You may wish that the number 0 were undefined if you get a 0 on the test, but unfortunately it isn't, right? How many people wanted to wish that 0 were undefined? Yeah, I wouldn't tell anybody either, right? Okay. Then, we have another division here. Division by 1,000 is easy. Whenever you divide by 1,000, it's like moving the decimal point 3 places, but to the right or the left. Division by 1,000 makes it smaller, so I guess to the left. 3 places to the left. 1, 2, and I need another 0 here, so 3 places to the left. And where did I tell you? Right here. The decimal point was here. It is now 1, 2, 3 places to the left. If you multiply by 1,000, the number gets bigger, then the decimal point moves 3 places to the right, or a number of places to the right. Okay. Are you ready for the exercises? You have plenty of time copying. We have about 10 minutes left to make it 2 hours, to make it 1 hour. You wanted to divide 2.6 by 7, and you wanted to round to the nearest thousandth, okay, thousandth with a th. So nearest thousandths, that means you're going to get 3 decimals. Do the division, get your 3 decimals, and I guess you got it made. And then we wanted to divide 140.273 by 0.0406. That means 140 and 273 thousandths by 406 10,000ths. About what do we expect? This is 4, this is 14,000. 4 into 14,007, about 3,500 would be my guess. See how close we are getting to that. Okay. Then we wanted to divide 2.235 by 4.5, which is approximately what? 4 into 20 would be about 5. This is 0.5. I expect the answer to be in the neighborhood of 0.5. Again, do the division, see what you get. And why doesn't this mouse work? We wanted to divide 8.25 by 2,750. What do you expect here? 8 over 24, 1 over 3, that's 0.3. And probably 0.003, something like that. Do I need that 0 here? Yes, I certainly do. Is there a decimal point in 2,750? Yes. It's not visible, but it is there after the 0, after the ones place. And then there are probably 2 or 3 more problems for exercises. Evaluate a squared plus 3b squared over 10a minus 30b, where a is 2.4 and b is 0.8. I don't know why my mouse doesn't work. All right. So open parentheses for a, for b, for a and b, and then drop in your numbers, and then square. Remember that the b squared, the 2 is only over the b. If you wanted the 3 and the b squared, you would put 3b in parentheses and then square it. So 2.4 and 0.8. We have another problem here. We have a minus 30b divided by 100a squared plus 3b squared. This dot, this multiplication symbol is really superfluous. 100a squared also means 100 times a squared, whether you put the multiplication sign here or not. You could also put parentheses in if you wanted to. And then we wanted to divide 16,324. We want to divide 16 and 324 thousandths by 100,000. Does the number get smaller or bigger? Good question. Obviously the number gets bigger, so you move. Does that mean you move to the right or the left? Okay, I don't want to show you the answers. We have about 5 more minutes left. How about doing a number with repeated decimals? Suppose you have 0.32929 and so on. Repeating decimals, let that be your number n. You want a decimal point here, so make it 1000 n, which is 3.292929. And you want a decimal point here, make it 10n, which is 32. The decimal point I said was right here. And this becomes 32. Ah, I messed it up. The decimal point needs to be right here. and the decimal point needs to be right here. So the 29 goes here. This is 990 times the number. And this is a string of zeros all the way to infinity, which I don't need. And 3 from 29 is 26, 326. So the number n should be 326 over 990. Can you reduce this? You can divide by 2. That gives you 16.3 divided by 495. Can you divide by 3 again? The denominator yes, and numerator no. Because the sum of the digits is 10. It's not 9. And let's see if we got the right answer here. I happen to have a calculator. I want to divide 163 by 495, which gives me 3.292929, and so on. The entire display is 0.29. Okay? So you're told that every repeating decimal is a rational number. I have shown you that 0.3292929 and so on, where the 29 is repeated. I've shown you that this is a rational number. It's a ratio that has two integers, an integer in the numerator and an integer in the denominator. Okay. I knew that if I didn't give you the answer to this, you wouldn't be able to sleep tonight. So that's what made me do it. And we have about 2 minutes left, 1 to 2 minutes left. How are we doing? This is video number 5. I have 13 videos altogether. Let me know. Okay. Enjoy the rest of your day. And enjoy your math.